derivation tree today we will discuss. We already have seen what is derivation tree long time before. Especially we are looking for this derivation tree for context free grammars. What is derivation tree? The derivation tree, we also can call it as past tree, or syntax tree. Is a tree which satisfies the following. To what we can say as a derivation? In generally we know that tree is the some data structure. But what is derivation tree? To say something is derivation tree, that tree must satisfy the following points. Okay? So in a tree there are nodes and edges. How can you look at the tree? What are the terms you can use for a tree? Nodes and edges. Okay? So every node of a tree should be labeled by a variable or terminal. Here variable means non-terminal, okay? So there should not be a tree that the tree is not having, if suppose this is a tree, okay? So every node of this tree should have some label. Suppose I am writing here A and B and this particular node is not having any label. If it is the case, I say this is not a tree itself. Okay? And in our case, we won't say that is a derivation tree in such case where I don't have any label on that. Root of a tree must be labeled by start symbol. So the tree always have a root and that root must be labeled by a start symbol. We are having in a context free grammar, we do have a start symbol for example. Okay, that root must be labeled by that start symbol. Third one. For nodes n1, n2, n3 up to nk in a tree, for x1, x2, x3 up to xk are the children's for a parent A if and only if there is a production A implies x1, x2, x3, xk. Is present in this context free graph. For labels, for a nodes n1, n2, there are some k number of nodes, and these are labeled by if x1, x2 up to xk, and these are the children of parent A. Then this kind of arrangement you can have if my context-free grammar is having a production of kind A implies x1, x2, x3 up to xk. So it clearly means that if you are having a production like A implies A S B, for example, if this production you are having, then you can have a, these are the children's in a derivation tree for the parent A. Suppose A, in this case I can have the children's A, S and B. This kind of children's I can have. So I can have this kind of arrangement in my derivation tree if only I have this production. This exactly is represented in the form, in some in general form as a description for understanding. Is it okay? Is it understood? For a nodes, these are the nodes, okay? For any node, for example, I will consider like this. There are some nodes. These nodes are suppose n1, n2, n3 up to nk. This node will have a label of x1, x2, x3, x4 up to xk. And these labels are, these nodes are the childrens of some what parent, that is what A. I can have this kind of arrangement if and only if there is a production of this kind. Okay, it clearly means that if I don't have this kind of production, then I cannot have this kind of arrangement. So to have a certain kind of arrangement of subtree in your derivation tree, okay, you should have this production. We will come to the example. Fourth, if A implies a null is a production, then there is only one child for a parent. If this is the production you are having, then what kind of arrangement you can have? This is the only one child for the parent A. Okay. Fifth one, internal nodes. I am talking about something internal nodes, right? Leaves. Okay. If suppose I am having this way. So what are these? What are the internal nodes for this diagram? Who are the internal nodes and who are the leaves? These three x1, x2, x3 are the internal nodes for this tree, and leaves are, all these are the leaves of the tree, and this is the root. In this case, I can consider. Okay, my root should not be start from A; it should start from S. Okay, here for example. So internal nodes must be labeled by variable. Internal nodes must be labeled by variable, not terminal or symbol. Sixth is leaves must be labeled by terminal symbols. These are the 6 conditions. The tree which satisfies the 6 conditions, such tree we can term as a derivation. I will take the example. I will give you the grammar. Yes implies A as B. Yes implies AAB. And A implies AB. Is it a context free grammar? Is this a context free grammar? Yes. So I am able to, I want to draw a derivation tree for this. As per my rules, what did it say? The root node should start by a start symbol. What is the start symbol here I am having? 2 start symbol I am having. Okay, I can consider this or this. Yes, first I am considering. So what are the children for this node S? A, S and B. And yes, this is a now see this is a label of terminal. It means it means that it is a leave. So this is a non-terminal. I can go for expanding it by substituting yes for the production. So what you can substitute? Do you want to substitute this? In that case, this yes will be expanded by the 3 children. These are A, B. So by applying the second production, I expanded this particular node. Because of that, I got 3 children for that, and S becomes a parent. Okay, so I can now here I got the leave node. Only the variable node I am getting is A, that I can apply the production and can expand it further. So I can again go for, I am only available, only possible production I can apply at this stage is third one. So I apply it, and this A will be expanded by 2 children, and the labels for these 2 children are A and B. So you can, whatever the 6 rules here we have discussed, you can clearly see that all rules are satisfied in this case. Okay? Getting? This tree is having a root as a start symbol. The tree is having as a second root for a particular level of tree. For example, A, S, B. This is the children of a particular parent S. Then I am having a production S implies A, S, B. That is my which rule? कौन सा था वो? Third rule. So I am having in this case x1, x2 up to xk, kx values are there, xk's are there. If and these are the children of parent A, then I am having a production of kind A implies x1, x2, x3 up to x. That is exactly. So these 3 are the children for this S. that I can have only if I am having a production of kind S implies ASB. So here again, if you look at the level, the same level children's A, B, I can have these children's for a parent S only if I am having a production of kind S implies AAB, that I am having. Getting? So next rules are what? All internal nodes must be non-terminals or variables. So you see any internal node, this is an internal node and this is an internal node. These are labeled by a variable. And all leaves are labeled by what? Terminals. See, this is the terminal, this is the leaf, this is the leaf, all these are the leaves and are labeled by what? Terminals. So if all these conditions, one of a rule that is a null, A implies null, that kind of production we don't have. In case of, if you are having a production of kind A implies null, what happens in that case? You will have only one son for a parent A. Get it? So here I can clearly see that all my conditions for a derivation tree are satisfied. At that time, I can say this is a derivation tree. Okay? If any one of condition does not satisfy, in that case, I won't say this as a derivation tree. Is it okay? Fine. Do you get irritated because of this sound? What should be the solution for this? Huh? Being an engineer, what would you suggest? Good. So why do we draw a derivation tree? For a given context-free grammar, why do we draw a derivation tree? Does it give us some information too? Or only for, why do we draw? So engineers work only for the benefit. If there is a benefit, then only he work. Otherwise, he just go on sleeping. Okay? So this derivation tree we have drawn for the purpose of getting a string out of it. So we can have a string by looking at this derivation tree, go on collecting to get a string, go on collecting the labels from this tree starting with the left to right. What happens? So this is my tree, this is the left, very first symbol I am having in this tree is A, then come down, this is a next symbol, this is a third next symbol, fourth symbol, fifth symbol, sixth symbol. So ultimately I get the string A, B, B, B. By this derivation tree I can get this string, and which is exactly the string of the context-free grammar given to me. So that string I term as a yield. Okay? The definition is the yield of derivation tree W. I indicate W, I consider W symbol for the string, or you can say is a string W belongs to L of G, language for G. This is a grammar G. And this is a one of a sentence W for my language, for my grammar G. So the yield of derivation tree is a string W which can be get from derivation tree by collecting the symbols from the leaves scanning left to right without repetition. You are not needed to repeat. Okay? So read it carefully. The yield of derivation tree is suppose a string W which can be get from the derivation tree by collecting the symbol from the leaves, scanning left to right without repetition. So the string from a derivation tree, you can have the yield of that string. I can consider as a yield of this tree, and that yield I can get as a string by scanning the leaves for the tree, and that is from left to right without repetition. I should not repeat, means this particular label I should not collect it for 2 times. Okay, record it for only 1 time. A, B, A, B, B, B. Don't collect like this. A, and A. This way. Don't repeat it. So this is the yield of. So to get the string from a derivation tree, what I prepare a derivation for a context free grammar. Okay. Now some more definitions are there. The context free grammar G there exists derivation tree for every string W belongs to the language G. This is one of the definition. Or I can say for context free grammar G, there exists a derivation tree for every string W from the language LG. What it means? If I consider a grammar G and that grammar G produce a language, it means that set of sentences it produce as a language, and for each sentence from this language, for each sentence from that language, you can have a derivation tree for that. Okay? So that specialty, that this is a property of context free grammar. For every sentence from the context free language, you are able to draw a derivation tree. That exactly this definition says. doing discussion, the moment you find some space in between the 2 points, so next definition, we are going for next definition. The derivation tree is a leftmost derivation tree if the node considered for expansion in a tree is a leftmost node. A derivation tree is a leftmost derivation tree if you consider to expand a particular node and that node is a leftmost one. Okay? For example, you consider this. The grammar ASBC, okay? B is AB and C is something. This way. My grammar is like this. The production is S implies ASBC, S implies AAB, okay? B implies AC, C implies CC, and C implies C. This is my random grammar. So if I ask to draw a derivation tree for some string, then I can start with like this. I start with first production. I number it. So by applying first production, what I can have? S as a root and 4 children I can have. A, S, B, C. Here in this case, which node you consider for further expansion? Yes or B? So if you want to have a leftmost derivation tree, then you have to consider the leftmost variable for further expansion. Okay, not B. And if you follow that rule, then resulting derivation tree can be called as a leftmost derivation tree. In this case, I will target not B but S. So I can apply the second production, that is what? A, B. Again in this case, this B is small. Okay. Which variable you consider for further expansion? A or B? A or B? That production we should give. Take A. I am considering one more production. A implies what? AB. Sit down, please. A implies AB. So out of these two nodes where you can apply the production for expansion, out of this A and B, which do you select? A, because it is a leftmost one. If you see, these are the labels. This is the first child, this is the second child of this parent, and this second child is having again 3 childs, and here this node is a second child of what? Second parent. Second child of this parent. Okay. So this is what? This is what? The leftmost variable. So I need to target this. If I want to draw a leftmost derivation tree, so I can expand by applying the production this one. So I do get A and B here as a children. So next, which node I can take for expansion? This B is a next leftmost variable that I should consider. I apply AC, third production. Okay, I don't have space here. I can make it. It is small c, huh? So B I am taking for further expansion. It is what? A. C is a capital C. It is a variable. And what is the next symbol? Next variable, leftmost variable. This is C. So C I will expand it. I can apply 4 or 5. C I can consider. C I have considered. So this C is the leftmost variable that I can apply, that I can expand by using the production 5. So in that case I get C. So what is the yield of this tree? What is the yield of this tree? A, B के बाद कौन सा है? After B, what is that? A is there, this one, then C, then C, and one more C is there here. Okay, this is the yield of my derivation tree, and most importantly, this derivation tree is a leftmost derivation tree because during expansion of tree nodes, I consider the leftmost variable every time. Okay. Similar way, you can have another definition. Definition 4. The derivation tree is a rightmost derivation tree. Okay. If the node considered for expansion in a tree is a rightmost node. Every time what you add, that is again important to consider. So in the next lecture, we will next lecture is a very important one because we are going to discuss a very important point as per the university examinations. Okay, hope all of you will be available for next lecture. So in the last lecture, what we studied is the derivation tree for a context-free grammar. Is it understood? Derivation tree, that was a simple concept. Today we will see the ambiguity in context-free grammar. Context-free grammar with context-free grammar, you may find that there can be a ambiguity in the grammar. What is meant by ambiguity? How to identify it? How to remove it? Is it ambiguity is a wanted or unwanted thing in a grammar, that we will see. If it is unwanted, then how do we remove that ambiguity in a grammar? Okay, see, it is discussed in the last lecture, last lecture, that how can we go for designing a context-free grammar for a given language. Okay, in that lecture we studied what we studied. कौन से grammar लिए थे हमने? C identifier and one more, integer numbers with sign. So for these two languages we had designed the context-free grammar. Grammar design किया था ना हमने. So after designing a grammar, you are required to see whether your grammar is really helpful or not. Really helpful in the sense, is the grammar designed by you is a something ambiguous or it is not ambiguous. That exactly we are going to see today. So what is mean by ambiguity in a grammar? Okay, so for a grammar, context-free grammar G, or you can say the sentence is ambiguous if that sentence can be derived more than one derivation tree. Look at this sentence. Come here. Look at this sentence. Read this sentence. The sentence is like this. The book selected information is given. Or you can say in a book. What is the meaning of this sentence? In a book selected information is given. What is mean by it? Is this sentence gives you a unique meaning to you, or does it giving you a ambiguous meaning? I am sure that two different people can draw a meaning of the same sentence in two different ways. One may read, in a book selected information is given. Another way I can read the same sentence, in a book selected information is given. I can connect this select sentence with information, or I can connect this selected sentence with the book. See, connect this select word with book, you will find one meaning, some meaning. And if you connect this selected word with the information, you will find another meaning. By having a single sentence, you are able to draw two different meanings. Is it true or not? जस्ट थोड़ा हंसिए खुलिए फिर आप लेक्चर लेंगे हाँ अदरवाइज देयर इज नो मीनिंग मैं ही उछल रहा हूँ स्टेज पे तो कुछ मतलब नहीं है पढ़ो उसको उतना ही पढ़ेंगे हम लोग आज पूरे लेक्चर उसको समझिए आप द इज दैट सेंटेंस इज एम्बिगुअस और नॉट चेक इट आउट है कि नहीं है व्हाट यू से मिस सर माय इंग्लिश इज नॉट सो गुड हाउ कुड आई is it the answer no you know good English okay so do you find this sentence is ambiguous what is the first meaning पहला मीनिंग क्या है if you read this select word with book then what it means that in a selected book information is given this way the meaning comes another way in a particular book selected information from within the book is given this way two information you can have with a single sentence in that case we can say this sentence is what can I say this sentence is an ambiguous sentence miss yes please stand up किधर घूम गई अरे lost shall I say this sentence is an ambiguous sentence I can say this is an ambiguous sentence because it is giving me two different meanings for a single sentence. Sit down please. So in a particular grammar what grammar do? What you can do with grammar? Why do we have grammar? Grammar क्यों चाहिए हम लोगों को? It gives us a language. Within the language, I will get sentences. So, grammar derives the sentences. If suppose a particular sentence from this grammar if that particular sentence from a grammar can be possible to have two different derivation tree, then I can say that sentence is an ambiguous one. See, read this. A sentence is ambiguous if that sentence can be derived with more than one derivation tree. अगर एक कोई भी सेंटेंस हम एक सेंटेंस के लिए दो डेरिवेशन ट्री अलग-अलग डेरिवेशन ट्री हम बना सकते हैं, तो ऐसे सेंटेंस को हम क्या कहेंगे? एम्बिगुअस सेंटेंस. Second definition. Second definition I can write. The context-free grammar G is ambiguous grammar if it I can write like this. If W belongs to LG is ambiguous. Please note down. In the first definition we defined what exactly the ambiguous sentence. that first define tells us the ambiguous sentence is one if that sentence can be derived, okay, with more than one derivation tree. Such sentence I can say as an ambiguous sentence. And I can say a grammar is ambiguous if one of the string from the language generated by the grammar is ambiguous. If even a single string from that language generated by the grammar G is ambiguous, then I can say that total grammar is an ambiguous grammar. Here I am having a string A plus B into C. This string or this particular string means I want to say mathematical expression. For mathematical which is involving two ऑपरेटर प्लस एंड स्टार, ये दो ऑपरेटर के लिए मुझे मैथमेटिकल जो स्ट्रिंग रहेंगे ऐसे फॉर सच काइंड ऑफ स्ट्रिंग आई वांट टू हैव ए ग्रामर. कैन यू डिजाइन ए context free grammar for such kind of sentences? All possible sentences or all possible mathematical expression with plus sign, addition and product. For these two operators, you is it possible to design a context free grammar? बना के देखो. Design the context free grammar for the mathematical expression involving two operator plus and addition and multiplication. My expression may be like this, and the variables may be you can consider from A to Z. Okay, so my expression may be A plus B into C plus D, or my expression may be A into B plus Z into Y. Any kind of expression. So you can see that this expression involved the length of this expression is something how much it is 7, and it is having in this expression mathematical expression involved two operations. These are multiplication and addition. So this is a valid sentence for my language to construct. This is another valid sentence. What is my language? My NG is what? Mathematical expression with addition, multiplication, operator, with symbol, with variable, from A to Z. This is my language. Language समझ के लीजिए क्या है. Please read that LG carefully. Language is a mathematical expressions, or you can say all possible mathematical expressions with addition and multiplication operator, and variable involved in that expression are from A to Z. So the example mathematical expression here I am having A plus B into C. Another way I can have A plus B into C plus D, A into B plus Z into Y, this way. Third, some way A plus B into C, A into B into C plus D plus E plus Z into P plus Q. This may be again it is a limited expression, okay? You are not having any parenthesis, and operator precedence is not considered here. But for the purpose of design of context-free grammar, we have considered this limited. But this is, if you see this sentence, it is having only two operators, okay? Addition and multiplication, and every variable is of length 1, and it is in between A to Z. So this is again a valid sentence from the language LG. So go for that. Go for designing a grammar. बना दिया? बोलिए. मेरे ख्याल से हमने देखा था last time. When we were studying the ambiguity, at that time we had discussed this grammar. So how way I can have? Yes implies what? Yes plus? Yes implies? Yes into yes.
Yes implies
ID. Or yes implies directly you can consider A or B or C up to side. See how easy this is. This way I can have a regular, sorry, not regular. Regular is already done with. We are discussing context-free grammar. This is the context-free grammar. Is it a context-free grammar? Yes. So, is it possible to derive by using this grammar? Is it possible to derive this string? It is possible. You can see. I can start with yes plus yes. I can replace this yes by yes plus yes star yes, or before that I can replace this yes by first yes by A, then plus yes, then plus yes I can replace by yes into yes. So I am getting sound from voice this side. Okay, I randomly pick one and throw it out of the class. Randomly. That selection will be random selection. So probability of expelling out from the class out of boys is equal. How much you are? Means 1 by 10. Probability is 1 by 10. Yes. So next I can replace this S by what? B into yes. A plus B. This yes I can replace by C. In this way I can come to the expression A plus B star C, what I had. So my designed grammar is able to give me what the sentence I had expected as a part of my language. Okay? And am I able to produce this particular sentence? Is it possible? Try to derive this sentence. All of you. Go for deriving this sentence. Boys, I am coming to check it. होता है? नहीं होता? चेक तो करो. होता है तेरा? Good. नहीं होता है? तेरा होता है? चेक किया क्या आपने? Girls. It can be derived. Is this sentence can be derived? Yes. What about this? This is too long. Derive होता है कि नहीं? नहीं होता है? It also possible. It means what in general you can say that this is the grammar, and that is a context-free grammar is able to give me all mathematical expressions with addition and multiplication operator, okay, with variables ranging from what? A to Z. And if you see, all the variables involved in this expression are ranging from the symbol A to Z only. And if I am having the string like A plus B into Q, ये डेरा होता है? Is it possible to derive this string? कैसे? Capital Q तुमच्याकडे नाही आहे. There is no symbol capital Q with you. That is why this string is not possible to derive with this grammar. Okay? So this grammar is very clearly told you what kind of sentences this language will have. It asks to have consider only the small letter symbols A to Z. So for that purpose it is designed like this. Okay? Now I will bring you one of a very interesting point out of this. For this particular string, which is belongs to this grammar or belongs to language generated by this grammar, I will draw a derivation tree for this. How should I draw? I should start with yes plus yes, and this yes I can reduce to what? A, and this yes I can replace, substitute the second production I can substitute, and or you can say this yes I can expand by applying the second production. In that case I get yes star yes. Further this yes I can reduce to B, and this last yes I can reduce to C. And what is the yield of this string? This derivation tree? The yield of this derivation tree is A plus B into C. So I can draw one more tree here. I can start with yes, and I can start with the second production and will draw a derivation tree. In that case, I will get this. And I consider this, I expand this leftmost variable, and I will expand it, this node, by applying the first production. In that case, I get this way. So I replace this yes by A, this yes by B, and this yes by C. And if I see the yield of this derivation tree, I get A plus B into C. So for a particular string, here I am able to have two different derivation trees which are really yielding us the same string. Isn't it? So I can say this particular string is an ambiguous string. Read the first definition. The first definition says that a sentence is ambiguous if that sentence can be derived with more than one derivation tree. Here I am able to have, for a particular string, I am able to have two different derivation tree. In that case, such string I declare as an ambiguous one. And further, the context-free grammar. Okay, G is a ambiguous grammar if the string belonging to this language LG is ambiguous. This is a string belonging to the grammar this, and it is producing a language LG. I can say, and if that particular string, if the string is ambiguous, then I can say this whole grammar G is ambiguous one. Now I declared this grammar is ambiguous. Why? Because that grammar is able to produce the string which is ambiguous one. Do you understand? When do I say a context-free grammar is ambiguous grammar? If that grammar produces a string which is ambiguous. Okay? Okay, this is about ambiguity of a context-free grammar. And this ambiguity, so this is a unwanted part of this grammar. What I needed, my grammar should be one which produce the sentences. For every such sentences, I should be able to have a single derivation tree. Means every sentences from a particular grammar should be non-ambiguous. If every string from a particular language is ambiguous, in that case the language is ambiguous and the grammar is again ambiguous unambiguous. What I said? I repeat once again. If the language is having all the sentences of kind unambiguous, it means that every sentence of that language can be derived by using single derivation tree. In that case, grammar of that language I can say as a unambiguous one. So this kind of unambiguous grammar I wanted to have. So that is my motive. But in case if my desired grammar is ambiguous one, which is producing ambiguous sentences, I needed to remove that ambiguity from that grammar. So there are the methods to remove the ambiguity that we are going to study further. But only thing here I wanted to highlight is that the designing grammar may have this kind of property which is really unwanted to you. That is ambiguity of ambiguousness of that grammar. So that ambiguity part we need to remove it. Okay? Do you understand?